Hi, thanks for joining. We'll be starting shortly. We are waiting for Gugan to join. Once Gugan joins, we will get started. Hi, Gugan. Thanks for joining.
Hi, Bhaskar. Hi.
We will get started in a while. Are you able to hear me?
Yes, I'm able to hear you. I'll just select just a minute. I'll start the video actually, like it's been disabled. Just a minute. Okay, hi.
Yeah, I'm able to see you and hear you as well.
Okay.
We will just go over a bit introduction about JavaScript and friends, and then I will give it over to you.
Okay, sure.
Hey, thank you for joining today. We have Gugan who has joined remote to speak on NGRX, and he will be giving us overview about NGRX and how you can use it with Angular. And a brief background about JavaScript and friends. We are a group of volunteers who have formed to run this organization, and the main motto of this organization is to conduct remote meetups and conduct annual conference. We also conduct workshops. So if you have any feedbacks, feel free to let us know, and we will plan to arrange those workshops accordingly. Our current programs, we conduct Vue.js Columbus Meetup group at Improving Columbus, and we conduct Angular online remote meetup and ReactJS online meetup. If you are able to participate in any of these, feel free to let us know. Our future programs include community workshops, study groups, and the main motto is to increase participation from all, and we want students to get involved more and get an overview about the current technical landscape. You can also help us by volunteering to conduct workshops or meetups or study groups. You can also help us on the day of conference. If you are interested to sponsor our group, feel free to reach out to us and let us know. Twitter, LinkedIn, Slack, or you can reach out to us through mailing list or email. We always feel free to share your feedbacks to us. And with that said, I will give it to Gugan. Gugan, it's all yours. I am stopping the share.
Okay, sure.
You should be able to share now.
Sure. Just a minute. Okay, are you able to see that right now?
Yeah, we are able to see
it. Okay, so sorry, let me get it started. Okay, hello, I'm Gugan Arumugam. I'm a Senior Frontend Developer at Tata Consultancy Services Limited. I'm a technical writer at Angular in depth. I love Angular and plain Akka and Java. I'm kind of like started right now traveling, and I'm kind of like obsessed with it right now. You can follow me on Twitter on Gugan Arumugam 93. Okay. So today what we are going to see is like, what is this new spec with NGRX? Okay. In June, NGRX introduced version 8, which changed a lot of features with in terms of with actions, in terms with reducers, and in terms of effects, reducing a lot of boilerplate and thus enabling it to be more easy, but at the same time, but more powerful too. Um, so what we'll go and see what a brief outline, like what we're going to see today. And it's first one is what we'll see, just a short intro on what is state management, and followed by why NGRX is most suitable for the perfect state management. NGRX Lifecycle, like how it from where it starts, where it ends, what are the other parts that are involved in it. So we'll look into that also. Then we will see about implementing NGRX, like what is required to do to implement NGRX. On that note, we will start talking about the new NGRX Action creators, one of the main parts of it. And next, we will also see how to create effects in the NGRX version 8 way. And then we will also see about the new reducer creators. Then we will go into how the testing is possible in NGRX. Okay, and that will be ended. Okay, what is state? A state is a plain object that holds information about the application at a certain point in time. So it can be your user application response or your user information. It's a UI data, user input, and it could be your it also could be your URL location data also. And so this so as you see, there are a lot of states to be maintained. So managing it becomes a little bit hard, and we always have to keep in sync. So we need something like perfect which does all these things. So so that's when NGRX comes into a picture. NGRX is like it's a Redux way to approach state management for Angular using RxJS. Here, this completely NGRX takes a approach wherein we tend to think everything in terms of observables, so that the push-based structure strategy becomes a default. Okay, so like all we have to is like we also have to describe certain what we need to do, and we don't have to worry like how it is being done behind the scenes. And we also doesn't have to pull the data from the application, and it also comes to us in this push based architecture. Okay. Okay, so people may be wondering why NGRX is the only suitable. There are also other libraries for state management, but I believe like they're doing it in the right way, and it's really good to do this. So why NGRX? In the sense like they provide a state management for creating maintainable explicit applications by storing single state and use of actions in order to express the state changes. Okay. So what you do is when your application starts to grow big, okay, maintaining lots of states is like a hard problem, right? So NGRX tends to resolve all those things and helps us to build enterprise state management in enterprise applications by making a single state through the application. So even if you're going to go with lazy loading and going to other models, lazy loading the models, we can create future states that go and append themselves to the root state. Okay, and here why they explicitly mention the use of actions in order to express the state changes is it's called something that we tend to call it like we describe what we need, and NGRX does it for us and gives us whatever response we expect. So we don't have to worry about what is going behind the scenes. Okay. So let's talk about the benefits of NGRX. Benefits of NGRX, we have like serializability, and then we have type safety. Type safety is promoted throughout the NGRX framework. And encapsulation. Right now, the side effects have been isolated, and everything whatever you see over here are pure functions. So side effects are something like if you want to make any external calls like database calls like WebSockets, and those things have been isolated. So why they have been isolated and how it helps us is it makes testing more straightforward. We don't have to worry about our components depending on our external resources. Our components becomes more straightforward and much more testable in this nature by isolating these side effects into separate functions. Okay, and we call them effects in Angular, but we will be seeing the effects in NGRX, and we'll be seeing it in another few slides. Okay. Next is the performance. Okay, NGRX is much more performant because only it triggers the chain reduction, like on based on the on push strategy, that is based on only when your state changes. Only when you start to reduce the new state and any state to particular state changes, then only your entire chain reduction strategy will run for Angular, so for NGRX, so that it helps you to it's much more performance in this way. Okay, that's like a principle that is being followed. So when this comes into picture, lots of questions will come, like why do we have to really go with NGRX? Like, can't we do it in NG with RxJS, only with RxJS? And yeah, you can do everything with RxJS, but I believe, like, why do you have to reinvent the wheel? Because when you want to follow all the industry standards and the best patterns and whatever you need, like rehydration and all those other sort of things, it tends to become big, and you come to know like whatever you have done is already existing in its library. So that's what we have started to read, because the NGRX has been following all the best practices, standards, and takes into picture. Okay, this is the principle what we follow when you think, like when you need to convince your boss or when you convince your co-workers, like why you need NGRX or when you need NGRX. This even for small applications or consider like bigger applications, they follow this principle. Okay, um, first we will see, like, if your state is being shared. Okay, like your state being shared by lots of components, lots of services, lots of lazy loading modules. Like when it's being shared across your entire application, you should consider. Then when your state is being hydrated, that is when your state has been that is persisted and is rehydrated from external storage. Assume that you are going from when you use using routing, we are going from one app to another app. You just persist your state in your local storage and then tend to retry them in your next application. So in that scenario, now you are persisting your state and you are rehydrating from external storage. So this is much more one of the much more suitable use cases for NGRX to be used. Available. A state that is always available when you re-entering the routes, when you're going from one particular route to another route, or state any trust transition that has to occur between while it is getting routed to a new route. So when your state needs available, yeah, you could go for NGRX. Retried. Okay, when your state has to be retried with a side effect, like you're working on something, you need some user, you got some user input and you got some state, but you need to retrieve that particular manipulator state from your external resources, like WebSocket, like push notifications, like how many notifications has been received for that particular article or something like that. So that is a side effect that will come in later stage. So when that kinds of scenarios are coming to picture, NGRX is also good. Impacted. When your state is not only impacted from an action from your own source, but also from other sources, like what we talked about, like hydration and the state persistence and all those sort of things. So the above principles come into play into picture, like it talks about impact. Okay, so this is a very good principle that you'll find it in your NGRX.io docs. Okay, so if you have any doubts like why you need to go with NGRX, that is more suitable to go take a look into that, have a read, and it will help you to think like, okay, let's go with NGRX or what we need to do with NGRX. Okay. Now let's see about what we think about implementing NGRX. There are like certain core distinct parts that you need while you are implementing NGRX. They are, and this is more or less the same way with Redux. If you guys have used the Redux pattern, it's kind of more or less the same way. But we tend to take this approach to the next level by using RxJS, and that's how it differs from the Redux patterns. Okay. First, the first part is your actions, your reducers, effects, and your selectors. Actions are like the like your commands, like your descriptions for unique events, like you want to, if you want, tells us like what you want to do. Reduces, they reduce your state based on whatever action it receives. It listens to that particular action and then it changes the state according to that. Okay. And apart from that, so we have something called as effects. And effects, these are the like the effects are the functions which are used to implement side effects in NGRX, like what we talked about earlier, like isolating the side effects from your state management so that testable testing becomes easy, like performance and all those sort of things. We listen to the actions and then we take necessary action through the effect, to the side effect. So that's how it works. And next is your selectors. Selectors are like picking a pieces of state from your application, from your entire state management, like from the from the entire root state. If you want only like particular piece of state, or you manipulate certain piece of state and then you recalculate it so that only that particular piece of state reaches to you. And you can so then what you call selectors. Selectors are like only picking up that particular part, whichever you require, and memoizing it. So that at the first time your calculation is being done, your function is being calculated, is being executed, and then your result is stored. For the every next time you call that particular function, it returns already stored value. So that's what the memoization occurs. Memoization in selectors means. And this memoization, only it gets stale or invalidated only if there is any state transition occurring for that particular input. If that input has any state has been changed for the particular input or for the particular state piece, then your entire functions will be recalculated again for the next time you call them. Okay. We are going to see the life cycle of NGRX. Okay, this is like a new diagram that's come up with version 8. Okay, thanks to Jordan Powell and for drawing this, for coming up with this wonderful diagram, like, and all the community members who gave their inputs in order to make this diagram much more clearer, because we were just wondering like there was this one part that was missing. Like we people who come into picture, they were always wondering like what is the really the life cycle, what is the mechanics behind them, like in a short way how it works, like so we were just wondering regarding that. So this diagram gives us a clear picture. So you have to see, right, everything starts from your component and it ends in your component. So there's no pull way. Okay, you go through one way and you get your data another way. So this is this unidirectional flow that is going on, right? You can see that, right? So that's what the beauty, one of the beautiness of NGRX is. So what happens is, from your component, you dispatch an action. Then from your action, what happens? Your action then calls your reducer. From your reducer, your necessary state transition function is picked up and your state transition occurs, and then it is returned as a new state, which is then stored in your store. From your store, like I told you before, any state transition occurs, it's then this particular input is data is pushed to your selector, forcing it to recalculate or reevaluate. Then the selector, on seeing and getting like whatever new data they're coming, it calculates again and stores the result for the next subsequent component, next subsequent calls by the component. Then from the selector, the data is pushed to your component. So when you see over here, you see that this effects part is completely isolated. So what is the effects part will do is, when your action calls a reducer to make the state transition, it listens to that particular action. Then if you want to do anything for that particular, after that action has called your state transition, then only your effects will be called. You have to know that clearly, like once your action is called your reducer function, and then for then only any effect that is being registered for that particular action will be triggered. So that then that effect will call your service and then any databases and gets the value and then pushes that service, pushes that data through a new action to your store. So assume that you have something like, we will see that example in the future, like in another few slides, like if you want to load all the to-dos, we have a scenario like whether the to-do architect call will be a success or a failure, so that we give an action like I would like to load to-do, and the reducer says, okay, you're going to load to-do. Okay, let me have a state ready for that. And then when the AFX listens to that particular action of load to-do and then calls your service and database and retrieves all your to-dos and gives it back to a condition through a new action, which depicts that all your to-dos have been a success and gives a new action to your reducer. Then new action picks up this state transition function for that particular action and then updates the store with the new value that's coming from your database. So this is how the NGRX lifecycle diagram works. Okay. So let me go for the next one. We're going to one of the main parts of NGRX, and that's your action. Okay. What is actions, or what are actions? They describe unique events that happen in your application. Okay. Since we are more tend to follow the RxJS pattern over here, we just wanted to reactively react to the user events, or any events for the matter. It doesn't have to be user events. It can be any routing events. It can be your any other kind of events that happens throughout your application. We can describe those events in terms of commands, and so that, and if you want to do anything to that for that particular event, you can do it in your using your effects or your reducer functions. Okay. These actions are inexpensive to create. Okay, they are very cheap and they are just like small objects to be created, so you don't have to worry about. So you can create as many actions possible, and that's why if you want to have, we had a scenario of having like load to do. We created 2 more actions to explicitly say, okay, this is the success one and this is your error one, and okay, for success do this, and for error do this, and for just loading do this part. So we have separated one particular load or add scenario into 2 more scenarios that's based on that particular action. So that explicitly saying, it's much more readable, saying like, okay, this event does this thing. So we have scenario for error, we have scenario for success. So that's becoming much more clearer to us now, right? Usually class-based action, it is implemented by class-based action creators by actually implementing the action interface, and that's your NGRX version 7 way. And right now, which we're going to see in another bit. Right now, we are going to use functions which are also action creators as functions. That's all going to be a new way. So the reason of switching from the class-based action to your function-based, it's because number 1, to reduce the boilerplate, and number 2, to make it much more type safe. So which you're going to see in just now. Okay. So this is your interface, action interface. So this is what describes you. Okay. So if your action, whatever you create, okay, it should implement this action interface. So it should look like this. What is being expected as an action. What it contains is, it contains a type string. Okay. So the value of this type should be in the format of source event. So what this pattern is what we call the good action hygiene, which is another great ngconf video by Mike Ryan and Brand Roberts, NGRX core team members. Okay, they have an entire talk regarding like whatever like what is a good action hygiene to be done used for creating actions. Okay, so that's a great article. I think it was in NGConf 2017 or 2018, I forgot. But that's how that's a very great video on conference video on that part. Okay, we will see about writing actions. So what are the things that are required for writing actions? Use create actions for creating actions. So this is this function. Okay. So from the class-based action, we have moved to this new action because I first start off like having it as a compare contrast between NGRX version 7 and version 8, but I don't want you to feel confused with regarding that. So I have made this talk in similar way that people who are started, who are already used NGRX version 7 might also feel more comfortable with this part, and people who are newly entering into the NGRX world, I could take a more advantage with this, because they don't have to worry about like how the previous things work, and just they can go in and just start writing, because these functions are much more smaller, much more easier, and much more readable in that matter. Okay. So what is this create function is? Okay, now it's kind of like a convoluted way, like saying this is a convoluted way of saying it. It returns a function when called, returns an object in the shape of an action interface. So our goal is to get an object which resembles the shape of action interface, so that we are still adhering to what class-based action implemented, like we are creating an class that implements the interface action, and so that we will get an object that similar, that is of type or of shape, that in action interface. So our end goal is to create an object which resembles the shape of an action interface. Okay, that's our end goal. We will see about how this create function works in another next slide. Then we have something called as properties or props. So what they do is they define the additional metadata needed to reduce the explicitness of class-based action creators for handling the action. Like if you wanted to, props can be anything. If you wanted to follow any config object, or if you wanted to pass any payload, for that matter, which you were doing in NGRX version 7 in your constructor, if you want to pass that. So those kind of things, if you wanted to do that, that's being reduced over here. So that's what here the term is changed into props for metadata. So that's your second parameter. So whatever input you want to pass to that particular action from the user, you can define them in your props. Okay, so that's what we're going to see. And one more important rule is, before you're going to see what is create function and properties and how to write actions, always write actions upfront. Okay, when you start your application, when you know what you need to do, for example, in the scenario of like you need to get all the required array of elements that should be shown in your dashboard, you just start writing actions at first before writing all your the service stuff and all your effects and all your reducers. You just start write action like, okay, I want to load my dashboard. Okay, and then I want to explicitly do something on the success of that, like show the recent one, and on error I would like to show a model, so that I have an action depicting the if what error scenario happens while loading the dashboard. So now I have three actions up front for one for that particular route, for example loading the dashboard. So I have these three things. So it's better to write actions up front, so it gives you like the idea like what to expect from your application, or what your application should expect. Okay. Okay, now we're going to see what action creators are. Okay, sorry. So this is this function, okay, create action. So it actually usually this create function create action function has two parameters. One is optional, your config object, that perhaps whatever you saw, because there are lots of scenarios where you will not need to pass any payload for that. Okay, like you don't really actually have to pass the input. Scenarios might be like whatever information you require for the particular action might already be available in the state. Okay, you can pull it from the state from your store, or your reducer can pull it from your existing state. So that's kind of scenario that it doesn't happen. Okay, and so in that scenario, like for example, if you want to load the dashboard where you don't have any user input information from the user, and so that scenario we don't have any payload, and this is an example to create that. So I told you an example like how your type object will look like. So it is better to follow that particular pattern, like source, then your event. So assume your source is your to do, and your whatever event you want to describe is load to dos. Okay, so this is what a function. So what happens behind the scenes, right? So what this create action gives you. So when you so in this bigger example, so you would be able to see that the interface action. We have an interface action because I will tell you why in another few minutes. So your const all to dos then you have a create action function, which gives you to do over here. So what you see over here is this, what this function returns is, it gives you a function, it returns you another function, which is of type object, which contains, which returns you an object literal of type. It contains property called type, which contains a string, whatever you pass into your type string, which is your create action. Okay. So what happens is when you call that load to dos, when you want to dispatch an action, then you call your load to do, you get an object literal, which has a property called type, and which is whose value is whatever we have passed in create action. So now if you see this object, it is similar to the shape of this action interface, right? So what we are expecting from the action interface, what we're getting, that is, we would like an object which is similar to the shape of the action interface. So that's how your action is being described. So now we got that right. So the reason of using this function type is to make your default values, may access default values in application much more easier, because so when you use it as a function, when you return as a function, then when you call them, you can just pass your whatever default values you would like to use, or any customized values or any new values you would like to use. You can do that, and which we are going to see in your next thing is your way of action creators. Why I'm calling it the 3 ways of action creators? There are 3 scenarios, where first scenario is no payload, which we saw right now. Your next is your when you have your props. Okay, that is when you have some user input to do. When you have some user input from your, that is received from your application and then pushed to your state manual for transition, then with that any side effect is happening, so we pass that input for whatever web service calls we need to make and get the data, then update the state. Okay, so this is this syntax. Okay, so we are going to pass this payload as a props function. What we saw is a props metadata property, right? So over here we saw like defining additional metadata needed for reducing exposure of class action. So what we are going to do that is this way. We are going to have a function called props. Okay, so what it's going to do is it is going to take whatever input you want to do. For example, you pass a props function if takes a generic type t. So for that, if you pass to do, so what that function gives you return back is like a property of that particular thing. So it gives you, it takes an input and gives you an object literal which contains a type and that input literal whatever you have passed it to your application. So you're saying, right, instead of having the default values, and when you tend to give it as an return it as a function, you get to have to override the default values. So this makes it explicit, or else we have to create that action in our components, which is kind of like a little bit hard thing to do, because when you start getting actions in your code, it confuses us. So if you want to have, so when NGRX older way was doing it for having all your actions in one particular file and then calling those actions. So, but when this enables that whatever that new of action enabled by the class-based action creators, but for passing the payload as an additional additional parameter to your action creators. So this is how it does. When you call add to dos with a thing to do called add let's plain concept. Okay, that's really my fantasy, but still how it goes. Let's see. What you get is, like I told you before, when you pass when you call a function with that it gives you an object literal of type thing to do and then your type, and this is what it gives you. So now you get an object. This is the object that is being dispatched by the store. So when your add to do is evaluated, you get an object thing to do with add let's plain concept, then type whatever the add to do type we have already created over here, and then with this function we are returning it to dispatching this object to the store. So So you might have a clear idea like regarding like how to how to create actions with no payload and how to create actions with payload. Okay. And so the next thing what we are going to learn right now over here is what does props function do that? Because when you see this prop function, so it might be confusing like what this prop function is actually doing, because we are not passing any input. Then how come it takes that particular property what we are giving via the generic T interface and it returns to you? So what happens in the behind the scenes, like, so this is this whatever object you are seeing over here, this underscore, okay, sorry, this underscore as colon props and p will undefined is the object that will be returned to you. But what type to expect, it's what being casted as underscore as colon props, and this property p is with to do, so that this property function is what gets picked up and is being converted into your function, which takes an input of the type whatever is being passed to it, and then gives you a literal which contains that input as well as your type. So that's really mind-blowing with how way they have done that. All the kudos goes to Nicholas J. Mason for implementing the TS action, which is a library which has done for all these created parts. And our NGRX team took that and made with the help converted into suitable for NGRX way to do it. And it's really mind-blowing, guys, with this new function way of creating actions. Okay. The third way of doing it is passing a function for this payload. So this is what we saw earlier. If you don't want to use the props function, then how you do that is by passing it as a function. So this response takes that you have property name, property called props in your response, and that's what you want to pass it as an input to your create action function. And then it really works in a similar way. Whatever we saw earlier over here, it is going to do this. It's going to return you the function which is going to have the same type. And then when called, it's going to return you the function, return you an object literal, which is very similar to the shape of action interface. So you might be wondering like, okay, now this contains an additional parameter, but it doesn't, it is not, but your action interface doesn't contains this one. Your action interface doesn't contains any payload property. But if you see now, when you work with class-based action creators or something, we just require the shape to be of the similar of action. So we can, so that the idea is to behind that is for your action to contain, you need to have a type property, because type is like the unique ID for the particular for particular state transition for any of that for that matter. Okay, so that's how it really works behind the scenes. So now we got an object which is of the shape action interface, and we got another additional input which is thing to do. And so that with that, now we are going to hit your backend and do whatever state reducer, and then if you have any effects listening to that particular thing, and it will create whatever services it has to be called and gives you back. Okay, and okay, sorry guys. Okay, now coming into your main part, which is your reducers. Okay, and so what are reducers? So now we have dealt with, now we have issued your actions. You are described like you described a unique event that is happening in an application. Now what we need to do is we need to listen to that. We need to act on that reactively on that those events. Okay, that's what we need to do, right? That's what we need to happen. So what happens is then it comes. So that's when the reducers comes into picture. Okay, reducers are pure functions. They handle state transitions synchronously. You have to really stress on this point that that state transitions that are handled by the reducers are synchronous. Even though we are the actions we are emitting or we are dispatching are asynchronous, multiple places we are, same actions could be triggered, and if you want, multiple actions could be triggered in for one particular unique event. So, but the state transitions for all those actions are queued up, and they're done synchronously. That's the main thing over here, because that's how, because else we would end up with race conditions, right? So that those state transitions are handled synchronously for that. So only one by one your actions will be computed, evaluated, then based on that your reducer will reduce the state and return your new state. For next every subsequent actions, the existing state, it will work on the existing state, and then with the new state, and then it will, that state will be passed, like all the new state modified will be passed to the next subsequent actions that are being called. Okay, so what happens is, it takes your latest action, dispatch the current state, and determines whether to return the newly modified state or your original state. So this is the state transition that I was really talking about. Okay, you have your state action, you have your action, that is the latest action dispatch. Okay, then you have your current state. So assume that you have three actions coming in. You have one action, it takes the first action and takes the current state, and then decides like what you decide like what you want to do. Then it modifies that particular state and it ends a new state. Okay, so now for the next action, this new state is taken into that, because that is your current state, and that action and whatever this thing it does and modifies and return. Or if you want to modify, you can modify, or you can want to just return it as it was to your as it is for that particular action. You can also do that part. Okay. Finally, you have to really keep in mind, like they are only responsible for deciding which state transition need to occur for a given action. Okay, so but what you want it to do is basically fully up to you. So it will pick what function, what reducer function you want to call for this particular action. That it handles reducer synchronously. Please don't forget that it synchronously handles state transitions. Okay, so we will see the create reducer function. This is what your create reducer function is. It takes two parameters. One is your initial state, and then is your on function. Okay, and returns an action reducer. Okay, so what is really will be happening over here? What we talked about, right? You have your current action, and then you have a function on function, which is kind of like an action listeners. Okay, you are really getting it to compute. So you have your initial state. Okay, and then for every subsequent on functions are nothing but it has a property called, it has two properties called your types and reducer functions. That is, I told you right now, right? You have an action, you have a reducer function for that. Okay, so this is what your on function is. So why it is given as a list parameter is, after that initial state, all you can describe multiple multiple on functions to it, and they are taken into an array for that matter. Okay, so what happens is, what it returns to you is a function which contains a state and then action for that particular. So that's what action reducer is. You have an action and a reducer function paired and given to you. So which when called with the correct initial state and the reducer action, will take necessary action for that. So now we will see an example regarding that. Okay, so assume that you have an initial state which is of type to do state, which holds a property called to do's. Okay, now we will create a reducer function called to do reducer. Okay, so which takes an initial state and a certain set of on functions. Okay, for that matter. So what happens over here is, for like feature actions dot add to do's, we have its state. What I told you, this is the thing. Okay, your on function takes two parameters. One is your action type, and then a reducer function which takes the state and the action and gives you whatever thing you need to do on that path. So this is what I was talking about earlier. So you have something for add to do's. When you decide, like if you want to add a to do to your backend, to your web service, to your database, like, okay, I have decided to do this thing, and your add to do's, I would like to attend Led Zeppelin concert. Now I need to store it. So next time I come to your dashboard and load all my to-dos, I need to see that newly added task. Okay. So what happens is we dispatch an action called add to do, which it takes a function, which is the state and the action, and gives you an original state. So this is what I was really talking about. You can either manipulate the state to do whatever you want, or you can just return an original state for that matter. So you have nothing to do with it, because we have split the strategy into two different things. Like when you are adding a to do, like I want to do this part only when it is a success. When I want to add it to my original state only if it's a success. And when my adding is a failure, I need to do a different action. So I'm explicitly splitting the success and the error part into two different actions based on my HTTP web service. So then in my add to dos, I'm like creating the function, and then I'm just passing that new state. I'm modifying the new state. That's how the spread operator does that, and creating a new state and new to dos and adding the to do to your own application. So this finally what you see is, right, if you see in all our reducer function, explicit function, it is always of this format: state and then your action. So what you're seeing over here. So it is going to be these two parameters is what it's going to be always in your application. So this create reducer function will return a function which takes all these actions and the respective state transition functions, so that when any action is dispatched by your application, for that particular action, it calls the respective state transition. That's what we're going to see next. So this so what happened? Okay, yeah. So now we saw like passing one single action only to the particular on function. We had multiple ons, but singular actions in each of the on functions. So right now, there are lots of scenarios, like for multiple actions, you do the similar action. For example, like I have add to do for which I'm passing the state. I'm not manipulating anything. In that scenario, I might have for some other delete to do also, for which also I will not manipulating the state. For example, I have a task to be added to my application. I have an action that triggers the removal of that particular task from the existing database. So for these two things, I'm not gonna make any state transition. So creating on functions for these two actions separately is like it's a little bit redundant. So what we can do is you can pass those multiple actions to your one single on function itself. So we are gonna take this example. We took this example from the creator spec of NGRX.io. So assume that there are two actions like type of foo action and we have bar action. Okay, so for both the actions, what I'm going to do is I'm going to do a same state. So my manipulation is going to remain the same. I'm either going to be sending back the initial state or the current state, or I will be doing the same manipulation that I'm going to do for either one of them if separately written. Okay, so this is what I created: a foo bar reducer, which it takes two actions like foo and the bar, and it takes a function which is of type state. And this property what you're saying over here is like, you saw the props, right? The props about data, or sorry, you saw the action that from here I'm dispatching the from there I'm picking up the type alone. I'm destructuring the type from the action object or the object. So from this object, I'm destructuring only this particular thing, and then I'm for the new state, I'm just passing this as an initial one type. So for the first time when I call foo bar reducer with the foo action, I get an array with a single string value called foo bar foo. Then if I call it on the same state, if I then call your foo bar reducer with the bar action, now I get two arrays. Two elements in my, not one single array, two elements in my array, which is a foo bar string and foo bar bar. Okay, so these are the two scenarios which we saw. To summarize, we saw first earlier of handling multiple on listener functions. You can, okay, if you're a little bit confused to like what on function does, it's kind of like an action listener. You can think it's an action listener for that for right now. Okay, so for that particular action, if you want to do something for the, and if you want the what the thing is like, on is something what it replaces switch conditions which were previously using in class-based action creators. Okay, so what on function does is it takes your action type and maps it to a respective reducer function, so that when you pass the when you pass any action from that, when you dispatch any action through your store, it picks up that particular reducer. This is your reducer state transition function and executes them. Okay, that's very much important. It executes them. So now we're going to say what this on function is. Okay, so like what I told you, it associates actions with the given state chain function. That for my add to do action, I'm just associating this state transition function to it. And always remember, in your on function, the state chain function or state transition function, what we saw earlier, like 2 parameters of state and action giving you doing your auto manipulation as you want, should be provided as your last parameter. This is because we saw a condition of multiple state transition, right? So when that scenario comes in, because your first all these things will be kind of like this kind of will be taken as an array because you have multiple actions working on that, and for all the similar actions, you have the same state transition function. And that's the reason why they explicitly ask you to provide state transition function as your last parameter. This is just to explain like behind the scenes what is happening in your create reducer. Okay, for it, I told you like from all your on array functions, what it does is like associate actions, right? So this is what we are doing from that particular action. We are creating a map of action reducers. So for that particular action type, we are setting your reducer. So now, even if you pass multiple actions to it, then for every single type, that same reducer will be appended to it. So your type is going to be remain unique. That's why your type has to remain unique. So this returns a closure function, which takes an initial state and an action. And with this, for every type, it picks that particular map.getReducer and returns that particular function to you to the store for it to execute it. So you still see over here, even though this one returns you a function, here we are just returning this type of this. It returns either a state transition function, that is your reducer function, which it takes 2 parameters, state and action, or your initial state, which you have passed. So you have to be very clear on that part, or your current state, for whatever that matter. It can be your initial state or it can be a current state. But if your action type is available, then you pass your reducer state transition function. If not, you just return the existing state as it is. You are not going to do anything further. Okay. So this so you might getting clear, right? Okay, you might have a little bit doubts in that, but please tend to reach me out on this particular thing, because understanding the mechanics behind like how it works really enables us to know the boundaries of what we expect to work, what we are working with, so that we might get to understand concepts much more clearer. Okay, that's the reason I had to go into that to explaining like what happens behind the scenes. So now we have something called as fx. Okay, so this fx is what we are going to do. So we talked about fx as being a side, as handling the side effects for us, like any UI. If you want to call your web service or WebSockets from that matter, you can use that fx. That right? We can use fx to call that, to listen to existing actions and then subscribe to them. And then for each and every action that's being dispatched, if you are listening to that part, we can call your web services and your what do you call it? Your web services, your WebSocket calls, and you can do lots of things that you want to be isolated from your UI. So your UI doesn't has to know how it receives the data. Rather, it has to worry about when I'm getting the data. So this is used for implementing side effects and so like I talked to you right now. So these effects are nothing but they are long-running services that listen to and observe of every action dispatched from the store after late transition. You should always understand that effects Okay, whatever action you are listening to an effect, that has to be that it will subscribe to that particular action, that it will start listening to action only if that action is dispatched after the last state transition. Because so it's much more performant, right? So it doesn't have to worry about so if you are called multiple times, you'll only for last state transition it will call you back on that part. So while performing this task, they are either synchronous or asynchronous. It can be asynchronous or asynchronous. If you want synchronous calls to happen like one function, after that only you have to call another function to convert, or if you want it to be an observable based action, that's really your thing. It can be anything. For that you can create any action, and if you want even to return a new action, you can also do that. Or if you don't want to dispatch any action, you just want to perform side effect, end of story, leave it as that. Yes, you can also do that, which we are going to see. Okay. So effect classes, they subscribe to the actions observable to perform side effects. So this action observable is what we saw in the second point regarding this long running services that listen to an observable of every action dispatch. So this is the actions observable. So this actions observable holds the stream of actions which contains all your store related things. So all your latest action that has been dispatched from your store, so that it helps us not to have all the actions that is dispatched, but only those actions has been dispatched after every latest state transition. Then your previous action queue, this one will be removed, and only your new thing will be called. Since it but you don't have to worry about anything. You are losing your action, but because it's subscription for every state transition, it immediately calls your action, so that all your state will perform your side effects effectively for all the actions you have dispatched. So let's see, these writing effects will mostly constitute what we saw earlier, like creates an effect classes to listen for events and perform side effects. Here, events, it's synonymous to actions. Okay, but why we are saying for listening events is because we are tending to treat actions as an object which describes events, right? So it's usually usual for us to say that we are listening to events. Okay, so it injects action services that provides an observable stream of actions dispatched after latest change, state change. So what we saw right now, this actions observable, which holds all your observable stream of actions. Okay. Now comes the main part. So how we are going to create is we with version 8, we have something called create a function for attaching that metadata to your observable stream, that is the FX stream. That is, you create a function and you then create an observable function which can be an observable of type. Then you subscribe, you attach that observable stream to your or metadata to your observable stream. So that is since you have to always start listening to your store for any state transition of occur, it's like you're hooking onto your action, or you hooking onto your actions observable. So that's what you saw in the lifecycle diagram, why we had it as a daughter base, separately isolated from your existing lifecycle, because they are like hooking. They put a hook onto your observable stream, action stream, and then with your effects, when you get any new actions after last stage, it calculates or it executes that particular function. So what happens is, for this metadata, what we are passing to that this one to your create effect function, it's registered to the stream, registered the stream to the store. That whatever data you are passing to it, it's used to put your hook onto your store, because we have to listen to the store for your new actions. So the store is the one who gives us your latest state changes, latest action that is dispatched after your state transition. We have a wonderful operator called as off-type operator, which is used to filter the actions. Because since actions observable, or the service which we are inject contains all the latest actions, but we don't want those things. We want to filter out all those things. We want only for one specific action. We can filter them out using this one, and we can do the necessary operation based on that particular action. So this is your create effect function. it takes two parameters. One is your source and your config. This is the config metadata we were talking about. So like this is the one which is used for passing any specific config to your create effect function. Okay, your source is something. Source is your function which contains your listening to your action observable, doing any data based on that part. So it helps you to give an idea, like this is what execute these side effects related to that particular action. So we will see an example. Okay, so this is the syntax for writing. So what we saw while writing this thing is create a class effects with our injectable service. So we have done that. Second step, we would like to inject the action service. So we have done all those things. And this is like a 2.1 step where we would like to add any external services, because we need HTTP client to make any external HTTP calls for this example. So we are injecting any external sources that are required. So now comes your main function, your create effect. Okay, so here we pass a function which returns you an actions subscription, and based on that action subscription we are working on some particular observable. We are working on that particular observable, so that we would like to return anything, any new action based on the success of the side effect that is being performed. Okay, either from v1/add to do or from your catch error, success on failure. So what really happens over here is you're getting a function, right? So what I told you is this is a function which returns you an actions observable. So this is it's going to be still an action observable, but this observable stream, okay, filters the required action, and then does your make a side effect and returns to you a new action. So what happens is when you subscribe to this actions observable, okay, you are automatically, after the subscription action, you are automatically emitting a new action to it. You are dispatching a new action to it. So when I told you in the NGRX lifecycle that the moment you call action, dispatch an action, it first affects the reducer. It calls your reducer and makes the respective state change. So this is the reason why we have isolated the effect, because once it worries about, once it returns to that add to do, I'm making no necessary state changes, but then I'm returning a new action to do my new state transition. So for this new state, and it will again call reducer, and the reducer handles the state transition synchronously and then updates your store. So it's much helpful, right? So this is how it works. So you would have got a clear idea regarding like the add to do part, and for the particular matter. So now we will see, like we have, if you have guys have any doubts, please just let me know in the Q&A session, which I had in another 5 minutes. Okay, so this is how it works with all these create effects. Next we will go for testing, because testing is much more important even when you're dealing with state management, because testing makes a lot of things much more easier, look for much more errors, and makes the testing much if you make any new enhancements to it, becomes much more easier rather than testing everything from start to end before. There are lots of helpers, test helpers has been created. To be wrong. There are few test helpers that has been created for the for you to help enable easy testing in your store and your effects. Okay, so for the first time we are going to see what are the test helpers that are available for the store, and they are one is like mock store. Okay, what is the mock store is? What you need to do is you need to provide this mock store. You have a function called as provide mock store function, which takes this mock store config object. You can use your set result function to change the initial state. Okay, so what these two functions are going to do, we're going to see it in the next slide. Okay, so this is just provide mock store. Okay, so what is a mock store is? For your entire store object, stored at for root, right? You are providing the end of store for that for the particular application. You can provide that. You can mock that instead of passing a real-time store into your deposit dependency. You can mock the provide store, and this is what it gives you, returns it to you. So it returns to you a set of providers which contains action subject, mock state, initial state, whatever config object you have provided, because this is your, what we talked about passing mock store config object to it, right? So this is what your mock store config is going to contain. It contains an optional initial state and your optional selectors. You have to really see that both these parameters are optional. So that means that you can even create and provide mock store with empty parameters. So you don't have to pass an initial state to it, and you can set your initial state in your individual individual it scenarios. Okay, so to see an example, okay, so this is an example from NGRX IO website. Okay, so which explains you like how the testing is being done. So if you see that initially I am passing a mock store config object. So this is my initial state. My initial state contains logged in boolean. Okay, this is what I'm going to be my type. So I'm creating an initial state with the logged in colon false. So that now to the provide mock store function, I'm passing this initial state. So what syntax was you are seeing over here with the code is like this Jasmine Marble syntax. It's very effective. It's very useful while testing observables, because they in turn give you an observable. They in turn help you to create observables without explicitly creating them. Like if you use cold and this scenario, whatever this, that means like you have an observable to which you have value has been passed, and so that you can test it. Like then when you call can activate. So what will happening over here is you can expect, like when you call the can activate, what it does it will return you this object, whether logged in is false or true. So it will pick that particular object and it will return to you logged in false. So now we have a scenario where our initial state is false. So that can activate will return you false. Then we can check it to be observable with cold of this with the observable that we have created using the Jasmine Marble with this, which contains an object whose value is false. So that now it's when you match both these things, it will be a valid passing scenario. Okay, so now for us one scenario has been tested. Now we have to worry about like what will happen when I have my logged in state as true. So now that means we are gonna change the state of the insert which is available in your store. We can't provide a new mock store for initial state with having logged in values fast. For that purpose, we are gonna change the state using a function called as provided by the mock store called as set state. So what this does is this in turn calls a reducer state function as a function. Okay, it's similar to calling a reducer state, but explicitly you changing you're modifying the existing initial provide mock store state to this new one, so that when you test it again with the true value, you will also both are true and is expected to be true. Okay, so apart from that, finally what we have is like mock selectors. Okay, these mock selectors, what happens is right now for now what we saw is using mock store as a test helper. Okay, now we are going to go one more step. Okay, like this mock store is we can use it for other things like handling the store to get whatever value you need for that matter. For what if in your component, if you're using selectors to test the scenario and you want to mock those selectors, instead of mocking the entire store, you want to mock that particular selector alone. So what the scenario for the particular component, what that scenario means. For example, lots of things like when you go with this presentation versus behavior components. In your presentation components, all you will be doing is like selecting the pieces of state, so that you will have a lot of selector functions over there. So if you want to override, if you want to provide a mock of those selectors, you can use this override selector function. Okay, and here at the same set result, same state, you have set the result of this memory selector to update this mock selector to return a new value. What is this memory selector is? This memory selector is the return type of your select function inside your application. So assume that you have a scenario over it, or for here, Okay, this is okay. So okay. So we are going to take the same example of AuthCAD. Okay, now for this time provide not store, we are not going to provide any initial state. We are going to make it empty because we are going to override the select task that we are using it with, that the AuthGuard is using it to select that piece of state. Okay, so right now I have a selector called logged in selector, which takes from the rule selector and whose value is of type Boolean. Okay, so what happens is I'm using the mock store to use the override selector from the, and I'm setting the value as initially false. So instead of passing the initial value, you can even override these selectors in this way to test your application for it to return the false or explicit value. And then for the particular next thing, like I want to change the set result. I want to change the, now initially we had used the set state to change the state of the initial state value. Now we can override the selector to set the current memory selector to be true. And then you can also check the for conditions for if the user state is logged in for that particular matter. The final thing is providing the mock providers mock actions. Okay, so you saw in your effects, so this is the part, this is a test helper for your testing effects, because you saw for your effects you need to have an actions observable, which is like a stream of actions. So for that matter, we can't have an original real-time injecting real-time actions observable for that, but so instead we can mock the actions, whatever we tend to listen to, what we tend to listen to. Okay, so this is how it custom goes. Like for the all the actions that are observable of actions available, we are mocking that actions so that you can pass, like you can like we told you, like for all the, it will effects will be listening to all the latest actions dispatched after the last state transition, right? So so for those actions, right, you can just as you can mock them, thinking like mocking them so that your effects will think like these are this last and new actions that are being emitted after your state transition, and that's what your provide actions does. So that and then when you provide mock store, you can pass your selectors for select customers, and then when you call selector with a value, you can test that particular thing. Okay, so I believe that is the thing part. So I would like to say thank you. So if you would like to know, have any questions regarding for that, you can just ask me. Okay, any Q&A. So if you have any questions, like you can ask me on this part.
Thanks, Gugan, for
Okay.
covering and providing details about NGRX. I hope we had a good information about NGRX. With that, I will leave it for questions. So before we start, I have a small question. Like,
okay, sure.
So comparing to Redux, I do a lot of Vue.js programming, and I have awareness about Vuex. So in Vuex, there is a feature like it will process the actions synchronously, meaning first in, first out, right? So
Yes,
in
yes.
NGRX, is it like first in, first out, or it's a random model?
So actually how it works is like in your first in, it is similar to the Redux pattern or same random. Instead of saying it is in random order, in what way your next is being called, like in emission, because since it's an observable, if you it's an observable stream, like what in order, what we can emit or action you emit in that particular thing. So that's how it reduces your state for that matter. But that's not really a concept of first in, first out, but I also go with like random orders only. So whatever actions are available in that observable stream, so it picks the first one and then it kind of like does the state transition, then it goes to a next action. And since
Okay.
since it's in stream, so we can't really collect like what order it's being emitted, or what is your first one or what's the next one, like how the Redux has it. The Redux, if you emit that first action, that will be your first one in your queue, and then only it goes to the next one. So that can be a pattern moving in NGRX.
Okay, so so do you mean that it will pick as and when the actions arrive in this stream?
Yeah, exactly. When you dispatch in what order you have, you dispatch an action to your store, and then your action subject, your actions, there's an observable which picks all these actions in its keeps in pipeline and then provides it to your store. And so that in what order it's being arrived, like whatever you said, it picks up the action and does your state transition.
Good.
So I hope like everyone like had an like a idea like, regarding this NGRX. So I hope it's went well.
So do you have any other questions? Yeah. So thanks, Gugan. Thanks for covering NGRX to our group, and we hope we will have you speak at our future events as well. Thank you for speaking to our group, and it's an early morning for you. So what's the time over there currently?
Currently the time is like 5:15 a.m.
Okay. Yeah. We really appreciate you taking efforts to speak to us. Thank you for coming, and thank you for talking today. And with that said, our next meetup is a Vue.js Columbus meetup, which will be on September. It is going to be on September 25th. We will be discussing about Vue and the new composition APIs. Feel free to RSVP for those in our meetup page. And with that said, thank you all for joining, and have a good time. Thank you.
Sure. I would like to say thank you for Bhaskar for like inviting me for this wonderful conference, and I like really love the great job you are doing on that particular part. So always happy to help the community. And if you guys also have any questions, you can reach out to me on Twitter. Also, there are we have also we can reach out to our core team members if you want to get a kick started with NGRX. And really, really NGRX is going like in norm way for big enterprise applications that I've been writing with Angular. So like hope to see that. Okay. So thanks you, Bhaskar. Thank you.
Yeah. So next month in our Angular meetup, we will be having Wes Grimes from NGRX team. He will be discussing about state management and how you can use HTTP file uploads and all those stuff with NGRX. We look to see you guys in our next Angular meetup as well. Thank you for watching today, and thank you for attending.
Thanks to all. Thank you.